Have you ever wondered how a tiny beam of light can cut through steel? How a thin light beam can help doctors perform surgery? Or how that little red light at the supermarket checkout can read a barcode in just a second? And even crazier, the same technology is also used for fiber optic internet. Used in concerts, used in the military, used in factories, and even used in space. All of that comes from one technology that looks very simple: laser. Most people only see lasers as tiny red lights, but behind that beam of light, there is some really interesting physics. There is a long history. There are scientific experiments. And there is technology that is quietly involved in almost every part of our lives. Today we are going to talk about how lasers work, starting from why lasers are different from normal light, how light can be amplified, why lasers can stay so focused, and how this technology became one of the most important inventions in modern history. Part 1. Why lasers are different from normal light. When you turn on a light in your room, the light spreads everywhere. Some of it bounces off the walls, some of it goes to the floor, some of it goes to the ceiling. Normal light is messy. The waves move in different directions. Different colors are mixed together, and the energy spreads out. Lasers are completely different. Lasers create light that is very organized. The waves move in the same direction. The color is almost exactly the same, and the energy stays focused in one narrow beam. That is why lasers look like thin lines, even though they are actually made of a huge number of light waves. Think about it like this. A normal light bulb is like thousands of people shouting different things inside a stadium. A laser is like one choir singing the exact same note. Everything is moving together. Everything is in sync. Everything is focused. That is what makes lasers so powerful. Even a tiny laser pointer used in an office presentation can still be seen from very far away, because the light does not spread out quickly. If you shine a flashlight at a wall from far away, the circle of light becomes bigger, but a laser beam stays small and focused. That is why lasers can be used to measure distance, cut metal, read barcodes, and send internet data. Because lasers have three main strengths. They are focused, organized, and powerful. What is even more interesting, the word laser is actually an abbreviation. Laser stands for light amplification by stimulated emission of radiation. That sounds very complicated, but the basic idea is actually pretty easy to understand. Part 2. How light can be amplified. We first need to understand how atoms work. Atoms have a center called a nucleus, and electrons move around that nucleus. To understand lasers, those electrons can sit at different energy levels. When an atom gets energy, maybe from electricity or heat, its electrons can jump to a higher energy level. But that higher state is not stable. The electron will eventually fall back down. And when it falls, it releases energy as light. This is the basic idea behind almost all the light we see. Light bulbs, fire, stars. They all work in a similar way. But lasers have a special trick. Lasers use something called stimulated emission. Imagine there is an atom sitting in a high energy state. Then a particle of light passes by. If that light particle has exactly the right energy, it can make the atom release a second light particle. The amazing thing is, the new light particle has the exact same direction, the exact same color, and the exact same timing. So one light particle creates another one, and then that new one creates another one, and then another, like dominoes falling. That is how the light inside a laser becomes stronger. The more matching light particles you have, the more powerful the beam becomes. That is why it is called light amplification, because the light is literally being amplified. Inside a laser machine, there is usually a special material. It can be gas, crystal, liquid, or semiconductor material. That material is constantly pumped with energy. until lots of its atoms are in a high energy state. Then stimulated emission begins, and the light starts getting amplified. One of the most famous examples is the ruby laser. The first ruby laser was built in 1960. It used a synthetic ruby crystal. That crystal was pumped with a very bright flash lamp, and it created a powerful red beam. Even though laser technology is much more advanced today, the basic idea is still the same. Feed energy into atoms, then use stimulated emission. Part 3. Why lasers stay so focused. One of the coolest things about lasers is their light can stay narrow even across huge distances. That happens because there are two mirrors inside the laser. One mirror reflects all the light. The other reflects most of the light, but lets a small amount escape. The light keeps bouncing back and forth between those mirrors, and every time it bounces, it gets stronger. Only the most organized and synchronized light survives. Eventually, that light leaves through one side as a laser beam. Because the light is so organized, it barely spreads out. That is why a tiny laser pointer can still hit a building far away, and the dot stays small. There is also a really interesting experiment. Astronauts left special mirrors on the moon. Scientists on Earth fired lasers at those mirrors, then measured how long it took for the light to come back. That is how they measured the distance between Earth and the moon very accurately. It shows just how focused laser beams are, because the beam can travel hundreds of thousands of kilometers and still come back. There are also very powerful industrial lasers. These lasers can cut steel, melt metal, and carve hard materials. The idea is simple. A huge amount of light energy is focused into a tiny area. That tiny point becomes extremely hot. Metal melts, wood burns, and hard materials can be cut. In car factories, lasers are used to cut car parts very precisely. In medicine, lasers are used for eye surgery, because doctors can control the beam very accurately. So lasers are not just about bright light. They are about controlling light in a very exact way. Part 4. The different types of lasers used in the real world. Not all lasers are the same. There are many different types, and each one has its own job. Gas lasers, for example, are often used in laboratories and factories. One of the most famous examples is the carbon dioxide laser. This laser is very powerful, and it is often used to cut metal and industrial materials. There are also semiconductor lasers. These are small, and they are used almost everywhere, from TV remotes, DVD players, barcode scanners, to fiber optic internet. Semiconductor lasers are very important because they are small, cheap, and energy efficient. There are also fiber optic lasers. These are used to send internet data. When you stream videos, play online games, or make video calls, there is a good chance that data is moving through fiber optic cables. And inside those cables, lasers are flashing extremely fast, sometimes billions of times every second. Those flashes represent digital data. So when you watch a video online, there is probably a laser working behind the scenes. There are also medical lasers. These are used to remove tattoos, treat skin problems, break apart kidney stones, and improve eyesight. Doctors use different kinds of lasers because different colors and wavelengths interact with the body in very different ways. For example, some lasers are better absorbed by skin pigment, while others are better for eye tissue. Lasers are also used in entertainment. Concert laser lights can create sharp and dramatic effects. Because the beams are so focused, laser shows often look futuristic and almost magical. All of this shows how one technology can have so many different forms and uses. Part 5. The history of lasers and the race to invent them. Lasers did not just appear out of nowhere. This technology came from ideas that started in the early 20th century. In 1917, entity, people, Albert Einstein, German theoretical physicist, suggested the idea of stimulated emission. At that time, nobody knew how to turn that idea into a real machine. A lot of people thought the idea was too strange. Decades later, scientists created something called a maser. A maser works like a laser, but it uses microwaves instead of visible light. Then in 1960, entity people, Theodore Maiman, American scientist who created the ruby laser, successfully built the first real laser. A lot of scientists at the time did not take it seriously. Some even called lasers a solution looking for a problem. In other words, they thought lasers were interesting, but not useful. The funny thing is, lasers are now used in almost every industry: healthcare, communication, transportation, electronics, military, and entertainment. Sometimes that is how major technology works. At first, it looks unimportant. Then people discover how powerful it can really be. Even today, scientists are still developing more advanced lasers. There are lasers for nuclear fusion experiments, lasers for detecting distant planets, lasers for cleaning space junk, and even lasers being studied for future weapons. This technology is still evolving, and in the future, lasers will probably become an even bigger part of our lives. Part 6. Why lasers are one of the most important inventions ever. If you think about it, a laser is really just light. But the way humans learned to control light is what makes lasers so amazing. Lasers changed the way we communicate. Because modern internet depends on fiber optics. Lasers changed medicine. Because doctors can now do more precise surgeries. Lasers changed manufacturing. Because factories can cut materials faster and more accurately. Lasers also help scientists understand the universe. Because laser beams can measure distance, detect tiny movements, and perform very precise experiments. The most interesting thing, lasers show us that a simple idea can change the world. It all started with a theory about how atoms release light. Then it became a technology that now exists in homes, hospitals, factories, internet systems, and even outer space. So the next time you see a laser pointer, or a barcode scanner, or laser lights at a concert, remember, behind that thin beam of light, there is a long history. There is complicated physics. There are scientific experiments. And there is one of the most important technologies humans have ever created. If you enjoy content like this, click subscribe and like to support this channel, and share it with your friends who need insights like this.